All right, camera's not working. Sorry, you get my avatar today. 8th grade, we're doing lesson 3.1, parallel lines and transversals. You should have already worked on your warm-ups while I was finishing up. I'll check them in a second. Once you've done that, you should be writing your key vocabulary, and you had quite a bit to write in your journals. All right, 8th grade, this parallel lines and transversals. Somebody tell me what a transversal is. Hold on, I need to test this. All right, Elena, tell me what a transversal is.
A line that intersects two or more
Okay,
lines.
speak in a normal voice so I can understand you.
A line that intersects two or more lines.
So sad. Yes, a line that intersects two parallel lines, actually. Okay? Somebody tell me what interior angles are, Max.
The angles inside a polygon.
Angles inside a polygon. Very good. And somebody tell me what exterior angles are. Sydney?
Exterior angles are when two parallel lines are cut by a transversal.
So let's look at this. Sorry, go ahead.
And for exterior angles are formed on the outside of parallel lines.
Exterior angles. Yes. All right, so let's look at this diagram. This is probably the main diagram you need to put in. So, 7th grade. You see these two lines running left to right? They have two little triangle tick marks here. Those two little tick marks are telling you that these two lines are parallel. Okay? Think of a railroad track. Okay, when you see the railroad track with the two little tick marks, you know this is parallel lines. Okay, they're cut across the two parallel lines by what is called a transversal. You can see this diagonal line. It's labeled T. 7th grade, I can still hear you. You're going to be allowed no talking. Joel, I need y'all to be quieter. So when you see the two parallel lines, the line going across them is considered the transversal. Okay, now let's talk about these angles. The interior angles are the ones that are inside this train track. You see these four right here? Those are all the interior angles. The exterior angles are going to be ones on the outside of the train track. Does that make sense so far? Now, when a transversal intersects parallel lines, there are corresponding angles, meaning for each parallel line around that, the angles are equal to each other. Look here. So this interior angle going on this train rail is corresponding to the same location angle on the other rail. So that means if I know that this angle right here is 110 degrees, what is this angle degrees?
110.
Does that make sense? So you can see the interior red, this one right here is corresponding to this one. So those will be the same angle. This one corresponds to this one, and the green to the green. Does that make sense?
Yeah.
This is highly important. You will be using this a lot because it's going to say, tell me the measure of this angle, and you look and see what's corresponding in order to find it. Side note, do you guys remember what is the measurement of the angle on a straight line?
180.
180, very good. So if I have a straight line, woo, that's almost straight. The measurement of this angle is 180 degrees. So if I have two angles on a straight line, let me get another color. So if I have this line right here, this angle plus this angle added together will always equal 180. So when you're trying to find measurements and you're moving things around, find the straight angle and then find how to find the opposite angle that you're missing the measurement. I'm sure that's some of what we're going to do. Any questions so far? All right, so let's do an example. Put this in your journals. Use the figure to find the measures of angle 1 and angle 2. So first we're going to look for angle 1. Right here is angle 1. Okay? Somebody tell me which two lines are considered the parallel lines. Josh. A and B. You see they're labeled A and B. Which line is the transversal, Kerwin? T. So when we're looking at the transversal comparing the two parallel lines, do we have any angles that are corresponding? Yes, we do.
Yes.
Which ones? Which ones? Well, that's the name of the lines. We're looking at the angles. Sydney?
the 110 degrees and the number 1.
The number 1 and the 110 degrees. See the location of those on here? Oh, let me get my little drawing. It helps. So this angle is corresponding to this angle, right?
Yes, ma'am.
You could also say that this angle corresponds to this angle, right? Now we don't have a measurement over there, so that doesn't help us. But because this is corresponding to 1, do we now know the measure of angle 1?
Yes.
What is the measure of angle 1?
110.
110. Very good. Oh, look, they drew pretty little green lines.
Nice.
Good. So now that we know that angle 1 is 110, can we solve for the measure of angle 2? Why can we solve, Aaron?
Does you can solve.
Why?
Josh.
No. What is this? It's a straight line, which means the measurement is 180. So if I know this one is 110, what math am I going to do? Nope. Subtraction. I'm going to say 180 minus 110. Does that make sense?
Yes.
I wish this wasn't such a fat marker.
I like that.
You can
So
make it
since this is 110, I can on my whiteboard. And I know the whole thing is 180. I'm going to say 180. Ooh, this is weird. Minus 110. And I subtract that and I'm left with 70 degrees. So I know the measure of angle 2 is 70 degrees.
Yes.
Question there.
Do you want us, for the example, that I was drawing?
You do not have to draw the picture. You do have to write that. And then for B, when you hear the word supplementary, that means they add up to 180. That's a key vocab word. Supplementary adds to 180. It's a straight line. Can anybody tell me what complementary angles add up to?
36.
Oh.
90. Very good. Complementary angle is a 90-degree angle, if I could draw a straight line.
From last year.
That is from last year, absolutely.
No clue.
That's okay.
I remember as an Excel.
That's why I wanted to see if you remembered. Yeah, if you hear the word complementary, that's a 90 degrees. So if there were two angles that are complementary, then they would add up to 90.
Yes.
Supplementary angles add up to 180. If you didn't know that, I'd write that in your journal. All right. Has everybody got this?
Yes.
I'll pause for a minute. Go work on your try-its.
Yes.
All right, so we're going to use the figure. This is example 2. Put it in your journals. We're going to use the figure to find. Wow, I can't read. Shh. 7th grade, you're distracting. Use the figure to find the measures of the numbered angles. All right, so first of all, which two lines are my parallel lines? Camila.
A and B.
A and B. These two right here, which makes my transversal. Aaron?
T.
This one going across. You see a pattern? They keep labeling the transversal T. Should help you guys. Later on they won't, but for now they're trying to help you. So, since I know that, I know these are parallel because they have these two tick marks, then I know I have corresponding angles already. So what's the first easiest one to find, Aaron?
75.
Okay, 75. Which is the corresponding angle to that one?
6.
Thanks, Aaron. Yes, 6. So we already know the measurement of angle 6 is 75. Very good. Now, can I find the measurement of angle 2? How would I find that one? Josh?
Well, I'm pretty sure 1 is the same as 75, so then it would be a supplementary.
Is this oh, that was a terrible line. Try it again. Is this a straight line? I mean, not my drawing, but that's on a straight line, yeah?
Oh, yeah.
So then this plus this would be 180. So to find 2, I just do 75 minus 180. So what's 75 minus 180? 105. So the measure of angle 2 is 105. And then Josh did have a correct statement, but I bet he doesn't know why it's a correct statement. Okay, and we haven't gone over this yet. If you look right here on this, you see how it makes an X?
Yes, ma'am.
When you have an X, you have an angle across from an angle. right? Does anybody have an idea what that's called? There's a name for this angle.
But I know why.
I'm glad you know why, but what's the name of this angle? Exterior? No. Nope. Because this one's interior angle, this is an exterior angle. Yes, say it. Vertical angle. These are called vertical angles. Okay? So whenever you see on one of your train rail tracks that it makes this X, see how it makes this X here? When you're looking at an angle across from an angle, that's called a vertical angle. Vertical angles are always congruent. So I know, because this is 75, that this is 75. Just by looking at it. Don't got to do any math. So what does that mean about angle 3? I know what 2 is, right? What did we discover 2 was? 105. So what's 3? 105. Now, since all of these have corresponding angles to all of these, do you automatically know what each of these are?
It's down there.
Write them down. I'm going to click it so it'll show you. Angle 1. Oh, I told you, vertical angle. They're congruent. So that's how you knew that angle 1 is 75. Angle 2 and angle 3 are vertical angles. And then it's supplementary to the 75, so that's how you got the 105. And then angles 5 and 2, yeah, here's all of them. They're all congruent. They're going to walk you through every single step. See? We matched all the congruent angles. Or corresponding angles, apologies. Which means they're congruent. So you should have a list. Angle 1 is, angle 2 is, angle 3 is, all the different measurements. Any questions on how we found all these measurements?
No.
Okay, so you know what a supplementary angle is. Say it. Adds to 180. You know what a vertical angle is. Means they're congruent. And they make the X. Okay? And you know what a corresponding angle is. It means it's in the same position on one railroad track compared to the other one. Good? All right, go do the next set of triads. Oh, it's just one. Do the one, try it.
Yes.
All right, so let's talk about these. Still dealing with parallel lines and our transversal. Let's talk about interior and exterior angles. The interior angles, as I said before, are the angles that are within the two parallel lines. Okay, so if I look at my set of train tracks, parallel lines, which 4 angles are considered interior angles here? Go ahead, Josh.
3, 4, 5, and 6.
Very good. So then exterior angles are on the outsides of the two parallel lines. Aaron, what are my 4 exterior angles?
1, 2, 7.
Good. So those make sense? Okay, good. Those are important to know, Ricky. Shh. If y'all are irritating him, which made him get yelled at, stop it. All right. Interior and exterior angles allow us to make up, or not make up, but mathematically have some rules that will help you solve for missing measurements. Alternate interior angles and alternate exterior angles. What do you think of when you think of the word alternate? Josh? Different? Okay. Is there any other words, Aaron? Huh? No, it's okay. Just throw it out there. Alternate. How about opposite? Is that kind of synonym? Okay. So when you think of alternate interior, you need to think of on either side. If I tell you to alternate your left foot to your right foot, you're going to step on your left foot, then step on your right foot. Make sense? Okay. So alternate angles means they are on either side of the transversal. So we're dealing with the transversal now. If you look here on this first diagram, we have the transversal cutting. I'm talking about interior angles, so the 4 angles on the inside. So far, so good?
Yes.
Alternate means on either side of that transversal. Let me grab my little marker here. So if I have this as my transversal, interior angles, alternate is on the left side and then the right side. Make sense? So that's one set of alternate interior angles. The other set would be this one and this one. Good so far? Rule applies also with exterior angles. Exterior means they're on the outside of the parallel line, so they're outside the railroad tracks. And again, follow the transversal, and they're alternating on the transversal. So this exterior angle would be congruent to this exterior angle. This exterior congruent to this exterior. Okay, let me show you a nifty little trick too. If I were to take this parallel line and smush them together, take the two railroad tracks and smush them together, does this and this become a vertical angle?
Yes.
That will help you remember that those have the same measurement. So if I smush the tracks together, all of a sudden it forms an X, and this is a vertical angle, and then this is a vertical angle. Okay? That helps me remember which angles equal each other. Okay? Doesn't work so well on the interior angles, but it works on the exterior angles. All right, any questions on all of these rules?
Yeah.
It's kind of a lot, but logically okay. All right, so go do... Oh, I lost my marker.
That was just a key idea.
Huh?
There's an example on it.
Yeah. Oh, I got to do the example next. You're like, don't stop talking. Sorry. Here comes the example. Is this 3? Example 3?
Yeah.
All right, so we're going to put this in your journals. If it loads.
Yes.
That just, when somebody smashes against the wall, I feel like they're dead. Hopefully they don't have a concussion.
Hawaiian.
All right. Oh, cool. So this is a real life example. This is what your freeways can look like and how they measure things. All right, so the photo, oh, this is the airport. Photo shows a portion of the airport. Describe the relationships between each pair of angles. So all of those little vocab words, alternate, interior, exterior, all of those, that's what you're going to use to describe things. So let's look at angle, let me get my little pen. Bright blue. Angle 3 and 6. So angle 3 is right here. Angle 6 is right here. First of all, which two lines are the parallel lines? Kerwin.
A and B.
Surprise, surprise. A and B are parallel, which makes my transversal the one going across.
Yes.
There's no T. Yeah, they didn't label it. So if I have angle 3 and angle 6, what kind of angles are those, Josh? They are exterior. Is there any other word we could add to that? Are they opposite on the transversal?
They're alternating.
So alternate exterior angles is how you would describe their relationship. That make sense?
Yes.
Not too bad, right?
No.
All right, let's look at 2 and 7. Get my little marker. I'm going to choose green. All right, so here's 2 and 7 with the transversal here. So which location are these angles at? They are interior. And then looking at the transversal, are they also alternate? Yeah, because one's on one side of the transversal, one's on the other. So these would be alternate interior angles. Make sense?
Yes, ma'am.
So you would also know they're congruent. So if you had any measurement in here, we could solve for all the other measurements. All right, go do the next set. 4 to 6, and I'm guessing self-assess. If it ever loads. All the way, yeah, go all the way to number 9, and then we'll do our last example. All right, example 4, question mark? Yes, example 4. The stairs have a 45-degree incline. Right here, 45-degree angle. That's what that means. At what angles do you need to attach a rail to do parallel posts so the rail is parallel to the incline of the steps? Hey, this is actual math that construction people use. Shocking. All right, so let's look at this. Shh. So looking at this, somebody tell me which 2 lines are my parallel lines. Elena.
The top one and the bottom one.
So you're saying this one
Yeah.
and this one.
I think.
Terrible drawing of mine. But yes, they have these 2 little tick marks here. They are parallel lines. Do we have any other set of parallel lines? Samuel?
Yes, the ones, I don't think they have letters next to them, but the ones going up and down.
Yes, you see this line, if I could draw a straight line in this line. They have 2 tick marks, okay? So we have 2 sets of parallel lines here, okay? And then this would be our transversal. Which 2 lines is that one transversing? It's transversing these 2 vertical lines, right?
Yeah.
Good. The parallel lines going this direction. Ugh, I'm terrible at drawing on this. So, got it. This line and this line has more than one transversal because this would be considered a transversal. So you could compare all of these angles and these angles. This would be a transversal. So you could compare all of these angles and all of these angles. All right, so you follow that? Because it'll get wonky here. So at what angles do we need to attach the rail to 2 parallel posts so the rail is parallel? All right, so we need to find the measurement of angles 4, 5, 6, 3, and 2. All right, so are any of these, we know that this right here is does anybody remember the name of this angle? That's a 45-degree angle. What was that?
It's a right angle.
It is a right angle, but what was the word? Complementary. Right, complementary. So that means this angle right here and angle 1 add up together to 90, right?
Yes.
So if I know this is 45, can I find the measure of angle 1? What would the measure of angle 1 be?
45.
90 minus 45.
Oh.
Because this is...
45.
Yes. So the measure of angle 1, since it's complementary, they add up to 90. So you're going to do 45 plus 1 angle equals 90, angle 1. So then you subtract and you get measure of angle 1 is 45 degrees. Question? Statement?
And then that means that 5 is also 45 degrees along with 4.
Oh. 4 is not 45 degrees.
Sorry.
Yes. So she's saying that makes angle of measure 5 45 degrees. Do you agree with her?
Yes.
Yes. Because that angle, if you're dealing with these 2 parallel lines, and this transversal, that 5 and 1 would be considered corresponding. So yes, now we know the measure of angle 5, which is 45 degrees. Hey, looky there. Comprende?
See.
All right, so now let's look at our other pair of corresponding angles. So let's look at 4. Well, first, can we solve for 4? Sydney?
I've already solved before. I just yelled at the answer.
Well, tell me how you solved.
Okay, well, it's 180 degree angle
Mm-hmm.
total. And so since 5 is 45, then I just subtracted 45 from 180, and that's 135.
Absolutely. They are supplementary, so they add up to 180. So 180 minus 45 gave her 135. So now she has the measurement of angle 4. Excellent. Now can we go look at 2, 3, and 6?
I think so.
So angle 6 and 7, up here, do they have corresponding angles that we have solved anything for? Okay, let's look at our parallel lines. If we deal with these 2 parallel lines, this one and this one, is this and this would be on a transversal so we could compare those angles?
Yes,
Yes.
ma'am.
5 is vertical to this one, right? I know it doesn't have a number, but you follow? So 5 is vertical to here, which means they're the same angle. So would that make 6 and this one corresponding?
Yes, ma'am.
Yeah, so what was 5? 45, so that means 6 is 45 degrees. Now 7 is right here. It would be corresponding to this one, which is vertical to 4. What was 4's angle? 135. So do we know the measures of angle 6 and 7?
Yes.
Yes. I don't know how they did it, but you got them right. Not that you can see. Move my face. Okay, and then does that mean we can solve for 3 and 2? Yes, so now I can compare this set with this set because I'm using these two as my parallel lines. All right, so what is corresponding to 3? 7. So what's the measure of angle 7? Very good. What's corresponding to the 2? 6. So what's the measure of angle 2? 45.
Oh, okay.
All right, I know that was a lot. Does that make sense?
Yes.
It's really easy. It's just wordy.
It is wordy, and you have to just try not to rush because you'll rush through it and make silly little not
You have to brain.
transversal lines.
You have to brain.
All right, good. That's the end of our lesson. You need to, I'll come back to this if you haven't written it down. You need to make sure for your homework you finish all the way through number 11. Okay? Through number 11. Any questions for me? All right, I'm going to stop my video.